Welcome back to a new video. In this video we are going to create a data science project using Python and its libraries pandas, matplotlib and scikit-learn. We are going to do exploratory data analysis and train machine learning models. Our data set is going to be about used cars and we are going to try to predict their prices with the features we have in the data set. You can either watch the video or you can download the data set and code with me on the video so you can add this project to your portfolio. I'm going to add the datasets link in the description of this video. You can download it from there. Let's start coding. We are going to start by importing the libraries that we are going to use. We are going to import pandas and we are going to import seaborn, and then we are going to import matplotlib.pyplot as plt. Then we are going to load our dataset. I'm going to say data frame is going to be equal to the, I will use pandas.read_csv, and after that I'm going to take my dataset name from here. I will just say copy and then I'm going to paste it in here, and I'm just going to check dataframe.head for seeing if it's loaded successfully. Seems like there's no problem. Also you can check the last 5 entry by entering dataframe.tail. I'm just going to look at the first 5. You can change this number, like you can just type 3 for seeing the first 3 entry. Let's check the first 5 and talk about the columns we have. So the columns we have is data frame columns. We have car name, year, selling price, present price, kilometers driven, fuel type, seller type, transmission, and owner. In car name we have strings, in year we have integers, here we have floats, we have strings, and at the last column owner we have integers. It has values like I think 1 to 3 because in the description of the dataset it says it's the amount of the users that used car. We can check that by reaching firstly the data frame owner, and after that we are going to call .unique like this for seeing the unique numbers it has. It's 0, 1 and 3. Also you can say number of unique and it's going to return 3. Like since there's 3 different values, it returns 3. Great. We can also get the basic information about the dataset using dataframe.info, and we can see that the data types, the memory usage, and other things from here. Great. Let's get the numerical summary. So we are going to say dataframe.describe, and here we can see that the minimum year is 2003 and the maximum is 2018 and the average is 2013. We can see the selling prices, present prices, kilometers driven, and owner in here. We can also check standard deviations for having an idea about the columns and etc. Great, so let's keep on going by checking if we have any NA valued rows. So I will say dataframe.isNA, and if I call like that, it's going to return booleans for every entry, and if I just say sum, it's going to give me the NA count sums column wise like this. Great. We don't have any NA valued rows, so we can keep going. I'm just going to check for the duplicates. I will say dataframe.duplicated, and if I run this we are going to see that we get booleans again, and we need to use sum after that, and if we use that we are going to get 2. We can drop them. For dropping them you can say dataframe.drop duplicates, and if you run like this, it's not going to modify the original data frame, it's going to return a data frame, but you will see that it's going to be 2 in here still. So what you need to do is you can reassign it to the data frame like this. It will work out, it will modify the original data frame, or the method I generally use is I will use in place equals to true. And if you do that and just check for duplicates again and sum after that, you will see that it's going to be 0 like this. Okay, let's get our columns again, and from here let's visualize the distribution of selling price, and let's use a histogram since we are going to visualize a distribution. So I will say data frame selling price, and after that I'm going to say plot, and I'm going to set the kind as histogram, and I'm going to set the bins as 20, and I will give a title like distribution of selling price. And then I'm just going to say plt.show for displaying it, and we can see the distribution of our selling price. Okay, let's do some more analysis on these columns. We are going to do group bys, visualizations, and after that, we will keep with feature engineering. And after feature engineering, we are going to get to the modeling side. So we are going to say, let's group our data by field type and calculate the average selling price. So in field type, let's see the different values we have. Dot unique, the function we talked about, and we can see unique values. We will say field type average price, and it's going to be data frame group by. We are going to group by field type, and we are going to take the values of selling price, and we will take the mean of this, and let's see the value of it. Great. So what group by operation returns is pandas series. As you can see, you can just manipulate this, like I'm just going to make this run and I will just manipulate it in here. You can just manipulate it, like if you want to transform this series into a data frame, you can just say reset index. You can just get that. Or let's do some more operations, like let's say you want to sort the values, so you can say sort values, and you can set ascending true or false based on your decision. If you say false, it's going to give it in descending order. And after that, you can do more operations, like let's see that you just want to see this tree, so you can say head 2 after that, and you will get the first 2. You can say head 1 after that, and you will get the 1. Also, you can do things like you can just say, I'm just going to make this rerun. You can just say maximum for finding the maximum value from this series, and you can also use other aggregation functions like standard deviation. You can just use this pandas series as you wish. So great. Okay, let's create a bar chart for average selling price based on field type. So we will say field type average price, and we will use dot plot after that, and I'm going to say kind is going to be equal to the bar, and then I'm going to give it a title like average selling price by field type. Great. So after that, I'm going to set an X label like field type, and after that I'm going to set a Y label like average selling price, and I will use plt.show at the end of this, and as we can see, it looks great. So they are in a random order right now. What you can do is you can just say sort values before plot, sort values, and set ascending as false for getting it in descending order, and you can use dot after, and you can see that it's going to be sorted right now. Also, you can change this to true for getting it in ascending order like this. Great. Okay, let's get the value counts for the transmission. So I'm going to say transmission that counts, and it's going to be data frame transmission, and I'm going to take the value counts of this, and we can just check how it looks like this. And let's create a pie chart with that. So I'm going to say transmission counts dot plot, and I'm going to set the kind as pi, and then I'm going to set auto PCT. I'm just going to show you what it does. By removing it, it shows the percentages on the plot. I'm going to say you are going to get familiar with this by using, and after that I'm going to say title is going to be distribution of transmission types, and I'm just going to say plt.show. So here it is. We are going to talk about two things in this plot. First thing, I'm going to remove this auto PCT in here, and you are going to see the difference. Like you can see the percentages right now. So when I add this, you will see that we have the percentages after adding it. I'm just going to make it work like this. As you can see, 87% and 13%. The other thing we are going to talk about is we are going to remove this count from here. So I'm going to say plt.ylabel, and it's going to be an empty string like this. So we don't have that count in here. Great. Let's group our data by seller type and calculate the total present price. So for that, I'm going to say seller type total present price, and it's going to be data frame group by seller type, and we will take the values of present price and we will use dot sum after that, like this. And we can check how does it look. Great. So let's do more group bys. Let's group our data by year and find the average kilometers driven. So we will say yearly average kilometers driven, and it's going to be data frame group by. We are going to group by year right now, and then we are going to say kilometers driven, and we will take the mean of this. And let's see how it looks like this. Great. So again, we can manipulate this for getting a better insight, like sort values ascending false. In this way we can get the maximum in here. Great. 2004 is the leader. Let's do a final group by. Let's group our data by fuel type and transmission and calculate the maximum selling price. So we are going to do a multi-index group by right now. We will say fuel transmission maximum selling price, and I will say data frame group by. Now we are going to give a list inside of this. We will say fuel type and transmission like this, and we are going to get the values of selling price, and we will say maximum after that. And when we run this, we can just check how it looks. Fuel transmission max selling price. Great. So now we have two index group by. We can just turn this into a pandas data frame from series like this, and you can see that it looks great. Okay, let's create a scatter plot between year and selling price, and I'm going to say plt.scatter, and we are going to say data frame year, and then we will say data frame selling price, and after that we are going to say plt.title, and we are going to give the title like scatter plot year and selling price, and the x label is going to be year, since in here we firstly passed the year, and y label is going to be selling price, and we will use plt.show after that. Great. As it can be expected, the more new cars is getting better prices. Great. Let's create a box plot for owner categories and their corresponding kilometers driven. So we will say seaborn.boxplot, and I'm going to give x is going to be owner and y is going to be equal to the kilometers driven, and after that I'm going to set the data as data frame we have. Then we are going to give it a title like, let's say, box plot of owner and kilometers driven, and we are going to give it an x label like owner, and we are going to give it a y label like kilometers driven, and I'm going to say plt.show after this. Great. Okay, let's create line plot to show the trend of present price over the year. So I'm going to say plt.plot, and I will say data frame group by year, and after that we will say present price dot mean, and after that I'm going to set the marker as O like this, and after that I'm going to say title is going to be trend of present price over years. I'm not sure it's a meaningful thing, but I'm just going to do that. X label is going to be year, and Y label is going to be average present price, and I will say plt.show at the end of this like this. I said I'm not sure because I'm not sure what this present price column represents, but it seems nice. It's a good grab. Great, so we can move on. I'm going to create two more plots before the feature engineering part, and they are going to be from group bys. So let's start by creating a stacked bar chart for the average selling price based on fuel type and transmission. I'm trying to cover the most common plot types for this video for it to be more helpful, and I'm going to say data frame group by, and it's going to be like fuel type and transmission. like this. And after that, I'm going to say selling price, and I will say that mean, and after that we are going to use that unstack. And let me show you at this step. Here you can see that what we have, and after that what we are going to do is we will say that plot after this, and I'm going to set the kind as bar, and we are going to set the stacked as true, and we can give it a title like, let's say, average selling price by field type and transmission. Also, for it to look better, let's just capitalize this like this, and after that I'm going to give it a X label like field type and Y label like average selling price, and we can just use plt.show after this. Great. Let's create a final plot with group bys and then keep with feature engineering. So let's create a line plot, and let's include kilometers driven over year for each field type. Okay, we can say data frame group by, we are going to group by year and field type. And then we are going to say kilometers driven, and it's going to be that mean after this, and we will say unstack again, we will say the plot, and we are going to set the kind as line, and we are going to set the marker as O, like this. And let's give it a title like trend of kilometers driven over years by field type, and we can give it the X label like year and Y label like average kilometers driven, and we can use plt.show at the end of this. Great. So these different lines like the orange and blue one caused because the values we have in here, I'm just going to make copy paste on here. We can see that we have inconsistent data like this. At some years we don't have data for this and for this, so it's appearing like this. Okay, great. Okay, let's recall our data frame again for getting the values that we are going to put into the modeling, and I think we can include, let's start by setting the Y. The value that we are going to be predicting is going to be the selling price. So I'm going to set the Y as data frame selling price, and we can decide on X right now. X is going to be, let's put year can be a good choice. Let's put kilometers driven also. Let's put fuel type, and let's put the owner count. Also we need to add data frame in here, and I think these are good columns for modeling side. I'm just going to call the X for showing you we have a data frame like this, and I'm just going to show you the Y. We have a panel series like this, and in here before starting to modeling we need to do one thing. These values are non-numeric and we need to turn them into numeric ones. Also, I think that we can also include the transmission in here, so I'm also going to put that real quick. I'm going to say transmission like this, and we are going to have that one in here too. So we have two non-numeric columns. We are going to do label encoding. So for example, the petrol is going to be 0 and diesel is going to be 1. After that, I'm going to say from sklearn import pre-processing, and we are going to do encoding with this. We'll use label encoder, and it's going to be pre-processing that label encoder. And after this initializations, we are going to do, we will say data and not data, we are using x, and we will say field type, and it's going to be equal to the label encoder dot fit transform, and we will say data field x field type, and we are also going to do the same for the transmission. In here we will say label encoder dot fit transform, and we will say x transmission. Great. So let's call x again, and we are going to see that columns are going to be numeric values right now, just like in here. Great. Okay, after this, what we are going to do is we are going to do the splitting. We will split our data by train and test. So we will have a training set, x train and y train, and testing set, x test and y test. And we are going to train our models on the training set, and we are going to test our models on a testing set. Like, we are going to test if model is performing good or bad on unseen data, because it's not going to see the x test and y test values before, since we only use the training set. So for that, I'm going to say from scikit-learn.model selection import train test split. In the end, what I'm going to do is I'm just going to say x train, x test, y train, and y test. And it's going to be train test split x, y, and we are going to set the test size as 0.2, which means that the 20% of the data we are going to use is going to be on the test set, and 80% is going to be on the training set, which we can also say, like, if we have 10 data points, 8 of them is going to be for the model training and 2 of them for the testing the model. Great. So after now, we are going to use these 4 for modeling and testing the model. And what we are going to do right now is we need to scale our data, since these values are at different scale. So I'm just going to say from scikit-learn preprocessing import standard scalar, and I will initialize this like standard scalar, and we are going to say scaled x train scalar dot fit transform, and we will give the x train in here, and we will say scaled x test is going to be scalar dot fit transform x test. Great. So we can use scaled versions or not scaled versions on the tree-based models. Not every model needs scaling, like decision tree and random forest, but I'm going to use the scaled versions of them for all of the models. Okay, we can start to the training our models, and before that I'm going to define a function for getting the model results. So I'm going to say from scikit-learn.matrix we are going to import mean absolute error and mean squared error, and I'm going to import numpy as np, and I'm going to define a function like model results, and we will give the predictions from the model using x test, and we are going to compare it with y test. So we will say print mean absolute error is, and we can just say dot format after that, and we will say mean absolute error, and we will get y test with predictions. The predictions we are going to pass into the function y test is going to be like this, and let's also print root mean squared error on model is, and actually let's say root mean squared error is, and we can use that format, and we will say numpy square root, then we will say mean squared error, and we will say y test and predictions. Great, here's our function. We can start to training our models right now. We are going to start by the linear regression. For that we will say from scikit-learn.linear model import linear regression, and after that we are going to initialize this like linear regression like in here, and then we are going to use linear regression.fit, and we will use the training data we have. We are going to use the scaled data, scaled x train and y train. After training our model, we are going to make predictions with that like linear regression.predict, and we will use scaled x test after that, and here is our predictions. Now it's time to compare them with the y test values we have. So we are going to set this like predictions linear regression, and after setting this like that, what we are going to do is we are going to call our function we defined at the last place. We will give the predictions we made, and we can see the mean absolute error and root mean squared error in here. Also, you can use other metrics, like I can just call from scikit-learn.metrics import r squared like this, and then we can say r squared score. We can give y-test and predictions linear regression. It's also an option. You can just move with the metrics based on your problem. Great. So let's train a linear model again. Let's train support vector regressor. So for that, we will say from scikit-learn.supportVectorMachines import svr. And then also what we are going to do in support vector machines is we are going to do grid search, hyperparameter tuning for tuning the parameters for optimizing the model performance. So I'm just going to say from scikit-learn.model selection import grid search cross-validation. How this works is it checks all the parameters given for finding the best performing one and then returns the one with the best performing one. So I'm just going to initialize the base model like support vector regression model SVR, and then I'm going to define a parameters dictionary, parameters grid support vector regressor, and we are going to give regularization parameter C values. Like I'm not going to give out of values, you can extend these values based on your wish. We can say 0.1 and 0.5. Let's set the kernel as linear RBF and polynomial, and then let's also we can set the degree. Let's give 2, 3 and 4 for the degree side. Great. Now we are going to initialize the grid search, like grid SVR is going to be equal to the grid search cross-validation, and then we will say support vector regression model, and we will give the parameters we have. Now we are ready to train our model. We will say grid svr.fit, and we will give scaled xtrain and ytrain for training our model. And then we can see the best performing parameters like grid svr.best parameters, and after doing that we will see that we get 0.1 for C, 2 for degree, and linear for the kernel. You can extend these values for finding different ones, like 0.01 can perform better since it picked 0.1. You can just try them, I'm not going to do. And the next step is storing the predictions inside the variable. We are going to make predictions with the model we trained. Grid svr.predict, we will make predictions using the scaled x test, and we will get the model results with this predictions grid svr. And here we have our results. Let's train a final model, and it can be a tree-based model. Let's train a random forest model. For the ending of this video, we will say from scikit-learn.ensemble import random forest regressor, and then we are going to say random forest regression model is going to be initialized like this, and we are going to say parameters grid random forest regressor, and we are going to give it a parameters like max depth it can take. We will say 5 and 10, and you can extend this value, so I'm telling it again. You can say number of estimators, it can be like 2, 5 and 8. I think these are enough. And then what I'm going to do is I'm going to say grid RFR, and it's going to be grid search cross-validation RFR model, and we will say parameters grid RFR like this. And now we can train our model. Again, since it's a tree-based model, you don't need to use the scaled versions of the X, but I'm just going to use the scaled version, like it's not going to make a big difference. Scaled X train, Y train, and here it is. Let's see the picked parameters like grid RFR.best parameters, and 5 for the max step, 8 for the number of estimators. And now we can make predictions on predictions grid RFR is going to be grid RFR.predict scaled X test, and we will just call our function predictions grid RFR, and here is our results.
Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I have a playlist named Data Science Projects where I have more than 20 data science projects with their datasets on that playlist. You can just reach to it from the cards of this video or the link in the description. See you in the next tutorial. Have a great day.